Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our day number 28. Lesson number 28. We've been covering this topic, adding and subtracting like terms. In the first 20 days of the videos, we learned how to evaluate algebraic expressions. Right now we are learning how to add and subtract like terms. This is our day number 28. Minus 5/3 x cubed plus 4/3 x cubed minus 1/3 x cubed plus 2/3 x cubed. Well, the question simply is, what do we get when we were to combine all the like terms? And here, all the terms are in fact like terms because they all involve x cubed. We have the same variable with the same exponents. Same variable with the same exponents, therefore all we have to do is just add up the exponents. Simply add up the exponents. We have negative 5/3 plus a positive 4/3 minus a third plus a 2/3. Well, negative 5 and a positive 4, a negative 5 and a positive 4 is a negative 1, a negative 1 and negative 1 will give us negative 2, and a positive 2, oh, what do you know? This whole thing is a big fat 0. It's a big fat 0. And I can show you, we can do it from the other end, from this end, and see if positive 2 and a negative 1 is positive 1. Positive 1 and a positive 4 will give us positive 5. A positive 5 and a negative 5 is just a 0. So this is just a big fat 0. That's it. That's all. Let's do one more. Negative 5/3 x cubed plus 4/3 y cubed minus 1/3 x cubed plus a 2/3 y cubed. Now what do we do here? These are no longer like terms because one involves x, the other one involves x cubed. So here we have x cubed here and x cubed here. We have to add them up separately, and then we have a y cubed and a y cube which has to be added up separately. That's all it is. They are no longer like terms. So how many x cubed we have? Negative 5/3 and a negative 1/3. Negative 5 and a negative 1 is negative 6/3, which is negative 2. Oh, so if you were to add up these two exponents, we'll get negative 2. So the answer here is, I'm going to erase this part now, we don't need it, we already figured out, is negative 2. So if you add up the exponents of x cubed, which clearly you can see negative 5 and a negative 1 is negative 6, so it's going to give us negative 2x squared, x cubed. And now let's do the y cubed. For the y cube, we have a positive 4 and a positive 2. Oh, this is also, of course it's also 2. What am I thinking? Of course it has to be 2 because we just found before that it's 0. So if this is negative 2, these two things bloody well add up to be positive 2. Because it's the same coefficient. And of course we already knew that it added up to 0. So if this one is negative 2, the only way you're going to get a 0, which is not the answer here of course, but the sum of the coefficient would have to be 0 because that's what we found before. So positive 4 and a positive 2 is positive 6. Positive 6/3 is positive 2. So it's 2y cubed. Let's do one more. Minus 1/3 x cubed plus 4/3 x squared minus 1/3 x cubed plus 2/3 x squared. What's going to be the answer here? Again, they are no longer like terms. They are no longer like terms not because we have different variables. We have the same variable. We see x is everywhere. X here, x here, x here, and x there. But they are different exponents. Here we have x squared. And these two involve x cubed. So this exponent has to be added up with this exponent, and this one has to be added up separately. And of course this we already know is negative 2x cubed, and the red one would be positive 2x squared. Just like before, except instead of y cubed we have x squared. The point I'm trying to make here is that the like term and unlike term here, these two terms, x cubed and a y cubed, were unlike term, not because this is x and this is y, although this is also this would be a reason, sufficient reason in itself, that they are unlike terms because one involves a variable x and the other one involves a variable y. But that's one reason. But you can also have the same variable and still this will constitute as an unlike term compared to this term because they have different exponents. They cannot be added together. You understand? For example, if x were 2, for example, if x were 2, if x were 2, then what it means here when we combine the like term here, if somebody says combine the like term here, what they are asking you is how many 2 cubed you have, how many 2 cubed you have, and how many 2 squares you have. 2 cubed and 2 squared cannot be added together. For example, if I have 2 squares and a 2 squares, well, 2 square plus a 2 squares is 7. Is 2 squares. Oh, I'm making a very big mess here. For example, if you have 2 squared and a 2 squares, 2 squares and 2 squares plus here is 2 squares. We can add them up. We are adding like terms. So like term here is 2 squared. But if we had 2 square and 2 cubed, there's nothing we can do there. They're unlike terms. It's just going to stay like that. Only difference is that in the algebra we do not know that this is 2. This is going to be a variable. This is going to be 2a squared and 5b cubed, or 5a cubed for that matter. Or in this case it will be a cubed because this is 2 and this is 2. So 2a squared plus 5b cubed, if somebody asks you to combine them, you tell them there is nothing you can do there. They cannot be combined. They are unlike terms. One is a squared, the other one is a cubed. It's like adding. It's like asking how many. What do you have if you have so many 2 squares and so many 2 cubes? Well, that's what you have. There's nothing you can combine there. You understand? You cannot put them together. Let's go on to the next problem. Before we go to the next problem, I'm going to check in the back of the camera to see how much time I have taken. Just give me 1 second. I'll be right back. Alright, let's do one more. Let's do one more. I'm going to erase everything. We don't need any of this now. I like to keep these videos under 15 minutes, and for some reason I was paranoid that it has already been 15 minutes, but it has not. It's barely 8-9 minutes so far. Let's do one more. A half a y, a third of a y, a negative third y, a positive 4/3 y, and a y. Well, how do we add them? Well, very first thing we notice is that they are all y's. Since they are all y's, they are all like terms. All we have to do is add up the exponents. There are two ways you can do them. You can find the common denominator and do it that way, which is more of a conventional way. Go back and watch, if you have not watched it, which I do not see any reason why you would not have watched it, because as I told you the first day of the course, you must go in sequence. Do not skip any videos. If you want to learn the algebra, this is up to you. Nobody's sitting there grading you. Nobody's told you to take this course. Nobody's giving you credit for it. You're not watching these videos because you're going to get so many college credits for it. You're not watching because somebody's going to grade you. You're doing it of your own volition. You're doing it of your own free will because you want to learn algebra. And if you want to learn the algebra proper way, you mustn't skip any videos. You must do all the problem that I'm doing in the proper sequence without missing any videos, any lesson. 2 days ago, I believe, day number 26, we talked about this conventional way and so forth. Go back and watch day number 26 so that you know what I'm talking about here. This is the conventional way where you find the common denominator and so forth. You can do it that way, but I don't want to do it that way. I want to find the lazy man's out. Let's combine the thirds and the halves together first. I'm going to combine all the halves, all the things with the denominator of 2 and all the things with the denominator of 3. So I see a 3 here, I see a 3 here. Let's make this one a 3 also. So a y is same as 3y over 3 or 3 over 3. So now we can combine all the 3's. So I have a negative 1, I have a 4 and a positive 3. Negative 1 and a positive 4 is positive 3 and positive, oh, it's just 6. All of this comes out to be 6, 6 third, which is 2. So it turns out that the sum of all of these three terms is simply 2y. Oh, 2y, and then we have on the front we have half a y. Oh, there you go, that's it. So sum of the whole thing is 2y, all of this thing is 2y, and half a y is just 5.5y. That's your answer. Not 5.5y, sorry. 2.5y, or 5 halves if you like. That's it, that was the answer, 5 halves. That's it. Should I go more into it or should I just call it a day? Let's just call it a day. Okay? One more time I'm going to quickly explain to you what happened was this was just a y. If it's just a y, it has a coefficient of 1. This is the third, this is the third. I wanted to make this the third too so that we can add up all the thirds first. So we have negative 1 here on the top, a positive 4 and a 3. And this turns out to be negative 1 plus positive 4 is positive 3 plus positive 3 is 6. This turns out to be 6 over 3, which is just 2y. So some of these, I'm going to put them in the box, some of these three terms turn out to be 2y. And then we have half a y here. So it's just half plus a 2 is 2.5y. That's all. Or 5 halves, if you like. I will see you tomorrow on day number 29. Okay? In the meantime, if you wish to get hold of me, you can send me an email or you can call me on the toll-free number. Go to my website, any of these website addresses that you see there, and you can get hold of me from via email or through telephone. Or you can go to kashwaniprep.com and get hold of me from there. Okay? Thanks.